Example 3 brings us back to that thing that we did at getting started, which was revisiting quadratic inequalities. Because in example 3, our one function, which I'll underline in green, is our square root graph, which you know what that looks like. And our second function, x squared minus 4, is a parabola shifted down 4. We again want to find an explicit equation and state its domain. So in A, for g of f of x, f of x is equal to the square root of x. And the function g says, well, whatever we put into g, it gets squared, and then you minus 4. So if you plug a square root of x into g, it's going to get squared, and then minus 4. What is the square root of x squared? It's just x. And so this simplifies to be x minus 4. And this is where you will be tempted to fail. Because it asks for the domain, and you'll be very tempted to say, what's the domain of a line? Everything. Perfect. A perfect fail. That's not right. Why is it not right? Because there was a square root earlier. And so what we have to imagine, if we think back to like our functions shop where you had f of g of x, means that you have f of x first as your first machine, and then g of x as your second machine after. And your first machine is the square root of x, and your second machine is x squared minus 4. And you would have on your shelf your never, ever, ever jar full of all sorts of numbers, right? And all the negative numbers are in there. You throw in a negative number and that first thing will explode. And so our domain, we can't throw in any negative numbers, even though our final equation simplified to a line, and lines have a domain of everything. We had a square root earlier in our equation, so our domain has to be bigger than or equal to 0. Otherwise, that first function will explode like we see in the picture. Right now, we're just dealing with real numbers and domains of that. Okay? In B, we have f of g of x. And g of x is x squared minus 4. And the function f says whatever you put in, you take the square root of it. So if we throw in an x squared minus 4 into f, what we're going to do and what we're going to get is the square root of x squared minus 4. So as opposed to A, in line 1 and B, we have no non-permissible values. Everything's good. And it's not until we get to line 2 in B that we have a square root, and we have a square root of a quadratic equation. So to find the domain of f of g of x, we need to find out, or we need to solve, when is x squared minus 4 bigger than or equal to 0? And this is a quadratic equality from grade 11. And with that quadratic inequality from grade 11, you can make it equal to 0 and find out that it's equal to 0 at plus or minus 2. You can draw a number line with those 2 points on there, and you can test. What happens if I plug in 0? If I plug in 0, I get negative 4 on the left-hand side. Is it bigger than or equal to 0? No. So this section will be false. What happens if I plug in a value larger than 2, like 3? If I plug in 3, 9 minus 4 is 5. That's true. Same thing when it's less than 2. If I plug in negative 3, that will be true as well. So you can solve it by plugging in values. And I'll always do that technique first because it really connects to curve sketching when you get into calculus. So you do this same strategy again in calculus. But you can also see, specific to this one, if I would graph x squared minus 4 as a parabola, can you see that it's this section and this section where your y values are greater than 0? Greater than or equal to 0? So when we go to write our domain has 2 sections. In interval notation, you can go from negative infinity to negative 2, square bracket, and then start again at 2 and go to infinity. Or in set notation, you would write x is less than or equal to negative 2, or x is greater than or equal to 2. Questions for practice for both example 2 and example 3 are 6 and 10.